Session 3, uh, industry terms definitions. Since this is IT class and the subject is related to information technology, therefore we need to understand few more terms. Some technical terms are there, so which we are going to understand in this session. The session is about what is syntax. We will understand the definition of syntax, example of syntax, and artifacts, and intranet. Can everybody put the mic on mute so that it does not create disturbance? Somebody is there. I can hear the voice, background noise. Thank you. Project charter, business model, and sandbox environment. So these are the few terms. Probably there are participants who are new to IT. These terms may appear them unfamiliar. So I would like to introduce these terms. Friends, this is session 3, industry terms definitions. So what we are going to understand in this session is some technical terms to be introduced in a very simple manner so that you understand them well and you know what they are, their meaning and everything. So let's understand this. The agenda for the session is syntax. What is syntax? Artifacts, intranet, which is a very common and familiar term in IT, project charter with respect to project and the system, business model, and sandbox environment. We're going to understand each of these terms with examples and with clear understanding so that there is no confusion. Now, this term is very widely used in computer science. When somebody is teaching computer science and any language, he uses this term syntax quite often. It refers to the way symbols may be combined to create a well-formed program in a computer language. It defines the formal relations between the constituents of a language and thereby providing a structural description of the various expressions that make up the legal strings in the language. I'll tell you, if I name few words, name, Ram, my, is, so these few words are not signifying anything, but if I put them in a proper order, they signify something, they convey a message. My name is Ram. If I quote another example, okay, comma or semicolon, when we use in our languages, you can talk about any language, let it be English or any other language. We use some rules, some grammatical rules. Syntax is basically the rules which make symbols a language. Without grammar, they are simple characters and words and alphabets, nothing more than that. So syntax give them meaning, actually, that the meaning is. From the computer language point of view, let me just quote this example. Okay, let me talk about this example. This is example. This very simple example of 4 words or 4 lines. Like you can see that hash include stdio.h, void main void, curly braces, printf, semicolon. Now, if you look at from first line itself, if you look at right from first character itself, that is hash. So it signifies something, it tells something. Include has a special meaning. This angular bracket or less than symbol signifies something. And there's a name of the file, it signifies something to computer language, C language compiler. Again, we have some words, void, main, void. I'm not going to explain the meaning of the words here, but I'm talking about the way words are written, the way line is terminated, the way parentheses are written, the way curly braces are started and closed. They are forming some blocks, building blocks of the language. If you look at another line, printf, where we have some parentheses and within that double quotes and some text is written in a double quote followed by parentheses close and semicolon. The semicolon is also a part of the syntax. So the syntax refers to how the words are put together to convey a special meaning for the language under consideration which we are talking about. This is the first program of C language, and it's very easy to understand. If we know the meaning of these rules and these grammatical rules, we call them as syntax. The syntax here is the C language starts with a special function or program or name called main. It could have been as simple as main. Right now it is void, main, void. So when we write void, it conveys some meaning. When we write another void, that conveys something. I'm not going to talk about the syntax is correct or not. Here there is a mistake also, and because the second line has a grammatical error. The grammatical error is this void, last void, third word in the line should have been into parentheses, not outside the parentheses. So it should have been void main parentheses start void parentheses close. So, and this line, if written as it is, this will give grammatical error or syntax error, and you will get the error message when you compile this program or execute the program on C language in compiler. Same way, the first character of the second line, capital V, is a grammatical error. It for compiler for C language, this should be small v. It cannot be in capital V, and small case and uppercase letters are different for C language. So just to explain the definition of void, this is the example where this program has two errors, syntax error, we call them syntax errors, and rest all program has a special meaning and syntax is correct, rest of the syntax is correct. Okay, this is how what the definition of the term syntax is. Okay, so in Foundations of Theory of Science 1938 by C.W. Morris, the syntax is defined within the study of science as one of the three subfields. Basically, these three most important fields which are used in computer science are syntax, semantics, and pragmatics. The term syntax, as I told you, it is a study of interrelation of signs or symbols or words, whatever you call them. Semantic is the study of relation between the signs and the objects which they apply. Like plus sign applies to two different numbers. So how plus sign is to be applied? Can we write plus before a number? Yes, we can write. Can we write plus after a number? We cannot write. So how the plus sign is applied to the symbols, that is called semantic. Okay, the study of relation between the signs and the object to which they apply. Pragmatics is the relationship between the sign system and the user. Means the how user treat them, how user understand them. We probably understand English language or the normal grammar, which is high level language, which we can read and speak. That comes under high level language. If you could see that C program, I could speak that and I could read that. But had that program be into 011000100010, you could not have understood anything, because the language of computer is language of 0 and 1. There is no other language. It is a language of true and false. There is no other language which computer understands. So what we need is something called interpreter, which understands our language and which convert it into machine language which computer understands, and vice versa. Yes, so these are the three terms: syntax, semantics, and pragmatics, widely used. Syntax is, as I discussed. Semantic is the study of relationship between the signs and the objects to which they apply, and pragmatics is the relationship between the sign system and the user. I was talking about the machine language and the human language which we speak. Okay, there's a hell of a lot of difference. In fact, as a matter of history, if you are interested and you love knowing new things, this language of 0 and 1 was developed and invented by Lady Ada Augusta Lovelace. Lady Ada Augusta Lovelace, she was daughter of Lord Byron. Lord Byron was very famous English poet. She invented binary number system, which formally became the language of computer, the machine language. In fact, there were three major developments. They are not in the slides. I am just giving you background. First was 1833, Lady Ada Augusta Lovelace invention of binary number system. Then 1854, a book published by George Boole with the name of Algebra of Logics and Thoughts. And 1866, development of analytical engine by Charles Babbage. These were the three major inventions which led to the development of modern day computer. Then comes the artifacts. Now I'm on this slide, artifacts. Now, observations in the scientific investigation or experiment that is not naturally present but occurs as a result of some preparative or investigative procedure, which means you follow some procedure, you do some research or investigation, and they became your principles or guiding statements, which are based on some experiment, based on some investigation. Okay, you are not on artifacts now. Okay, now you are on artifacts, or now declarative. So it is not changing. Okay, okay, 1 second, give me 1 moment. Now it will change. Yeah, I'm going full screen, but yesterday also I was going full screen, but now I understand what the problem. Let me do it now. I'll do that now. No problem. I'll get the full screen now. I got it now. Now you will see the full screen only. Now you see the declarative requirement statement, and now artifacts back. Now we are moving in the full screen. Now we are able to see, right. Now there will be no problem. Okay. So artifacts, as I said, is observations in the scientific investigation or experiment that is not naturally present but occurs as a result of some preparative or investigative procedure. Okay. Now, requirements, artifacts, what do we need, and what are these investigative procedures or some preparative some statements, some principles which are based on some logical facts. Okay, they are like declarative requirement statements. Then we have use cases, we have data models, process models, and business rules. These are all comes under artifacts. We are going to understand each one of them one by one in this presentation itself. Okay, these are all artifacts, examples of artifacts. Each artifact was adapted to document one aspect of the requirement. Like if I talk about declarative requirement statements, they specify one aspect of the requirements. If we say use cases, they specify second aspect of the requirements. Data models, process models, all these comes under that category. Okay, could they be used together? Yes, in the entire document we use them in our business requirement document, and we are going to use them definitely. Without this we cannot talk about a system, because all these things are to be considered overall, because system is not one component, it is a group of components, group of entities working together. So we have to look at each aspect of this. So what is this declarative requirement statement, the first artifact which I was talking about? The declarative requirement statement format is a direct assertion of one property that is essential for an IT system to perform its functions. That categorically means that it is declarative, means they don't follow any order or flow upon any information system. There are some statements, declarative statement, like they have these verbs like system must, or the software must, or software should. Now this must or should or shall, they specify whether this requirement statement is mandatory or it is just optional. So they are declarative statements only in the system. Okay. Such statements are usually part of larger group or list of requirement statements and can be documented at various levels. Okay, from high level requirement, initial stage itself, the top level requirements that are often documented first in the project, to a detailed statement used as input to design and as the source of test cases. The common structure of this kind of statement is, the system must, that kind of statement which starts with this. Let's look at examples of this declarative requirement statement. Let's look at the example. you know uh, uh, the variations on the structure include the following. We'll look at the examples also in the next slide. Variations on the structure include the following. Sometimes the structure is changed, referring to the solution instead of the system, like the system must or the solution must or the software must, depending on that, in what context we are using the statement. Okay, as information or other type of system is not always what is needed to meet the requirements of the business. So business analysis can identify the need for procedure or process change or instance, for instance. Okay, now these are variations, like as I told you, variations on the verb must, such as shall or will. There might be some variations on this verb also. A must statement is often interpreted as mandatory requirement, while the statement using other verb mean the requirement is optional or vice versa. Okay, or nice to have that requirement. If multiple verbs are used in a set of requirements, the specific meaning of the use of each verb should be clearly defined within that context, within that statement. Okay, because these are legal terms, the shall or must. Tomorrow they are going to land you into legal suit, or you are going to face legal problem if you don't understand these terms carefully and you don't write these terms and specify this, whether it was must or optional. So therefore be careful of choosing the words while preparing the document also. It should not be that you use shall wherever it was mandatory requirement. You should use must there. That is the important legal definition when we use this. Now these are examples, declarative requirement statement examples. For example, the system must provide security such that our manager can view salary data only for their own reporting staff. Now this is a statement. When we are preparing document, programmer is going to implement this. The project manager is going to include this in the project specification while doing the program, while developing the software. So we as a customer, the customer is saying that we must provide some kind of security to the manager so that he can view salary data for only their own reporting staff or subordinate employees. So this specify a declarative statement, declarative requirement statement. Another example could be system must calculate the monthly payment for a loan given that the interest rate, the amount borrowed, number of payments and the payment frequency. So these are mandatory statements. So this statement right from the system must calculate the monthly payment to the last, the payment frequency, this all comes under a declarative requirement statement. Look, I am looking for this thing, I am looking for this security, I am looking for this calculation of monthly payment. So these are simple requirement statements. Okay, and we call them as declarative requirement statement. Then we have use cases. Use cases are simple, that you take some example I explained yesterday also. For example, enter the login name. So user will enter the login name enter the password, user will enter the password. Okay, the moment it is entered, then user will go to the registration page or his account page. So this we call it as use cases. There are two basic types of use cases. One, a multiple step interaction between the actor and the system. Now actor here is the user or the client who is testing the program or is working on the program or working on the software. So it is multiple step interaction, as I was just giving this example of login name and password, and click on the login button and then you go to the account page or dashboard. So this is a use case actually. So a multiple step interaction between actor and the system, which relates to user interface design and captures the required functionality the system must provide to support the interaction. As I was talking about these, if you read the sentence once again and you recollect my example, that I'm talking about a login page, where the login page will ask two credentials from the username and the password, and the third is the button. The button will take the user, check the credentials and forward the user to, or redirect the user to the dashboard of the user. So this is basically use case. Then there is another example. There is a second type of use case, which is a single step or occurrence format, where an actor initiates the use case, which is provided some input or some precondition, and it executes a set of actions like calculate something or retrieve or store something else. Now I was talking about that login name and password itself. The moment you click on that button login, that is a single step. Now once the login name, that login button is pressed, your credentials must be verified, must be checked, or must be saved. When you register yourself, the form, when you register yourself to a website or to a software, or when you register yourself to a software, your account is created, then this is one step. Your data is stored. That button, login or register button, when pressed, this data, whatever is captured from the user, is stored in the database. So this is single step. When the button is pressed, the button itself specify use case number 2, a single step, the pressing of that button, which is storing the data or saving the data or doing some calculation. So this is one example. There are n number of examples which can be quoted here to do some calculation or to do some processing. So any clicking of something which is triggering some program or storing something or getting something or calculating something or doing some processing refers to the single step occurrence format that produce a result of interest to the actor, like enter interest, loan amount, duration or tenure. Okay, these are multiple things, and but the moment you say there's a button given at the bottom, suppose with a link that okay, calculate the interest. The moment you calculate the interest, it does some processing and it will give you the result. So this is one step. The button is pressed, calculation is done, and the result is displayed to you. There may be multiple actors also. The set of actions that are first defined are those that will normally execute if no exceptions or other variations occur. Also known as happy path, as some authors or instructors in my past called it as. We call it as happy path, means because that is the most easiest way for programmer to follow, because programmer follow the logics. So whatever you are specifying, the developer will understand this. Okay, I need to display this, I need to do this calculation, I need to display this tab or this result. Okay, or this is the processing actually which is to be done in the backend. So these are called use cases. Then comes the data models. Data models are used to define data needed for a system to use or control. There are various data models, so we are not going to into the detail of data models like hierarchical data model, networking data model. There are different kind of data models, and they often form the basis for the definition and creation of the databases. So because a database here refers to the facts, we need to store the facts, we need to store some information into our system. So how that is to be captured and how that is to be stored, there's a lot of details about this topic, and definitely it may take 4 or 5 days to explain the entire concept of data models and how they are implemented. But I will take you, quickly to the introduction or how it works. It is a very simple manner. The most common format used to capture data requirement is the entity relationship diagram. The database designer or the database administrator, we call them as a DBA. A DBA first create an entity relationship diagram or entity relationship model. Let's look at this, what this model is. Okay, this is ER modeling, entity relationship modeling. If you see here, I have employee written in rectangle, then works in, then we have another rectangle where DEPT, which stands for department, is written. Basically, this diamond is called a relation. So employee works in department. Employee has some attributes or characteristic, like employee have employee number, employee have name, employee have salary. The employee number, salary, name, these are called attributes. Okay, so the entity here is employee. Employee number, name, salary, these are attributes. Works in is a relationship. If you look at little carefully, under employee there is another diamond, okay, and that is reports to. If you look at this diamond is taking input from employee and again related to itself. Why? Because this relationship is called manager, and manager is, since manager is also an employee, therefore I am saying employee is related to itself. We call it as the relation. Okay, and you can see there is another entity which is called since, or another attribute. So we may have this relationship. Okay, we may have a relationship, we may have this relationship with one or more of the attributes. Same way, department also have some attributes like department number, department name. Okay, so location. This is a simple possible example to make you understand what is ER diagram or ER model or entity relationship model. Entity refers to anything which can be separated from the rest of the universe. Some entity which has some characteristics, like pen is an entity, person is an entity, okay, employee is an entity. So anything which has some characteristics, has some attributes which we want to store in the database, we call them as entities. And the set of such entities, like group of employees or group of departments, is called entity set in entity relationship model. So this is one simplest possible example of ER model. So these are data models. Actually, there are many such models. As I told you, hierarchical model is there, network model is there, ER model is there. So a lot of modeling examples are there which are beyond the scope of this training as placed. But yes, you should understand what are different data models. The takeaway should be, I know what are data models. There are many data models, but I know what are data models. They actually refer to how the data is to be captured, how the data is to be stored, or how the data requirement to be captured from the user. Okay, that refers to the data models. Then we have process model, exactly same way, as a format for documenting system requirements. Process models can have negative impact on the resulting system. The process as it exists at the time of requirements documentation has often been hard coded into delivered systems. These are kind of blockings. We should avoid this hard coding of process models. Basically, when your process is rigid and is hard coded within the system, that will definitely create problems later on. Why? Because later on you have to, you know, if you have to change the software, if you have to change the system, This is a hard coded process. So this is going to create problem, because then you need to change the entire system somewhere which is related to this process. I can tell you an example. We are living in homes, and my house, for example, I have a drawing room. Now I want my drawing room to be divided into two parts. That's going to be difficult because it's a multi-story building, and I cannot have bathroom in the drawing room, or I cannot have a separate partition, right from top to bottom, so I cannot divide it. The process is one set or established fact, or the process which is there in the system. It should not be hard coded, it should be flexible. When the process needs to change, the system cannot support a different process, because computer is a machine, and the system which we are developing is done in the computer. So therefore, when the process needs to change, the system cannot support the different process. So then is the scenario, that will be the situation where we are going to face the problem, and the business starts to adopt or create workarounds to get the work done despite the constraints of the system. So then we get into the process of change, and change management is as good as new project actually. So that's going to be a difficult big problem. That is, by definition, that is process model. So automation of the current business process should not be a system requirement. That is the statement and underlying fact, that current business process should not be the system requirement. In fact, more generic process and workflow softwares have been developed over the years to specifically support rapid change in process, adding or changing or reordering process steps as needed. So therefore, if we have to develop a process, we have to have a solution within the software to make the process dynamic, to make the process that can be done by doing using a modular approach, which we will understand. Okay, and that process can be, we can have dynamic processes which can be created and changed during the software development and system development, and after the implementation also. These tools are enjoying a new high profile business process management, we call it as BPM products, as companies look for ways to integrate disparate systems, and vendor look for a front end to service oriented architecture approaches. A lot of service oriented architectures are available nowadays to implement this process model dynamically. Therefore, this is again has become dynamic now. Earlier it used to be static or hard coded in the program, but now we are doing it dynamically, and we are implementing the software part of it within the system itself, so that we can have dynamic process models. We call it as service oriented architectures, which you'll understand at later stage. But right now, the concepts. Business rules. A business rule is what? It is a statement that defines or constraints or constrains some aspect of the business. It is intended to assert business structure, or to control the influence of the behavior, of the business. The business rules that concern an information system projects are atomic, that is, they cannot be broken down further. So when we say business rule, it means a statement or a simple principle or simple rule that defines the constraints that is mandatory for the business to run, without which we cannot run the business. So that is called the business rule, simplest possible definition. Intranets is a pure IT term, pure technical term. Intranet basically is a networking of computer. When we have one computer, this is not intranet. When we connect two computers so that they can interact with each other, that is intranet. Then what is internet? Internet and internet, or these are the terms which are used with respect to the boundary or the scope of the networking. If the networking is done within the building or within the premises, we call it as intranet, which means the local internet or internet within the boundary of a building. Okay, so Intranet is basically intra plus net. So an intranet is an internal or private internet used strictly within the confines of a company, university or organizations, as I said, within the scope of the building or the organization. Inter means between or among. Hence the difference between intranet or internet. Okay, this is what the difference is. When we say internet, it is network of networks. If I have 5 laptops here and they are connected to each other so that they can communicate with each other, we call it as intranet. But if my intranet is interacting with intranet of your company, then we call it as internet. So some formal definitions of intranet. One is, for example, intranets help present and circulate boundary objects. Another definition is intranets supported the creation, sharing and use of knowledge. And intranets are organizationally restricted. So it is networking of computers within the organization. By definition, that is what intranet is. Project charter, commonly referred to as a charter, is a high-level document used to initiate, propose, define and promote the understanding of a project business need and provide information supporting the decisions to further investigate the need or solution. So in a way, it is a complete document which is shared with the vendor initially, service provider initially, which actually explain everything about the project. The information is gathered and documented during the identification phase itself, as I said, of the project, and may be refined during the initial phase. And this is the first step. If you recollect the image shared with you yesterday session, last image, that is the first part. So project charter is basically the information which is gathered and documented during the identification phase of the project itself, and may be refined during the initial phases, subject to approval of the project sponsor who is getting the project done. The charter describes the project's purpose, goal, scope, impact, cost and success criteria. If you look at these 5-6 words in this paragraph, you clearly, I really expect that yes, you understand this, that if the document of the project is of 100 pages, these are first 4 pages or 2 pages, the project charter, which will, because the purpose is not the entire document of 400 pages, it should be of 1 line or 2 line or 1 paragraph or 2 paragraph. Goal, scope, impact, all these things. So this is the first few pages of your entire document. The charter is approved by the project sponsor and provides the project manager and his or her team with the authority to apply organizational resources to the project activities, because he needs some resources also for the implementation of the project, for the project activities. So this will authorize him, to apply the resources to the project activities. So this is what the project charter is. In relation to charters, what are the responsibility? Who is responsible for what? In relation to the project charter, or simply the charter, the project sponsor is accountable for project and therefore must make sure that project has a completed and up-to-date charter. The project owner is responsible for providing all the necessary information to the project manager in completing the project charter. And a project manager, once assigned, is responsible for creating the charter and receiving approval from the sponsor and the owner. The project manager is responsible for the maintenance and updating of the charter. So these are the 3 main rules who are responsible for this charter. So everybody has a role to play in it, project sponsor or project owner or project manager, in creating the charter. Business modeling. A business model is conceptual structure supporting the viability of a business. This very common term used everywhere. Anybody who's starting a business, the first question is asked, what is your business model? So when I say, what is your business model? If you ask me, so what is your business model? My business model is we do marketing, we identify the people who are looking for websites, we take their requirement, we develop websites according to them, and we earn money. How we are going to survive with this business model? Because we are getting new websites daily, we are designing websites, we are developing softwares, and we are into corporate training also. So this business model is good, successful, we are getting a lot of work. So we have specific target segment, so we identify that. We identify the actual need is there or not, or is going to die. So this business model talks about how the money will be generated, what will be the return on the investment, and who all are your clients. Identifying all these things comes under business modeling. A specification describing how an organization fulfills its purpose. All business processes and policies are part of that model. According to management experts Peter Drucker, a business model answers the question, who is your customer? What does the customer value? And how do you deliver value at an appropriate cost to that customer? This is a simple question, and if you answer this, you know your business model. A business model is similar to a business plan in its makeup and content. However, a business plan specifies all the elements required to demonstrate the feasibility of a prospective business, while a business model demonstrates the elements that make an existing business work successfully. Because in order to make the business run successfully, you actually need to understand your customer. You need to understand what value you are giving to a customer at a justified cost, of course. Okay, that is the definition and that's the concept of business model. Then we have sandbox. If you look at the background image, there are some children playing in the sandbox, and that itself is the definition of this. What these children are doing, they are making some buildings or working and playing, and then they recreate it, they destroy it, they recreate it. Okay, nothing is permanent here, and they are flexible. This gives them the flexibility to make changes whatever they want to, and just play with it. All right. So sandbox is a type of software testing environment that enables the isolated execution of a software or programs for independent evaluation, monitoring, or testing. So what does it mean? It means we give independent environment for the developer, that you do one thing, create your program, develop it, work with it, test it. Once it is done, you hand over it to me. So at various stages we will have testing environment, because we cannot directly put it into production. We cannot directly take the software to the develop this production environment. We first need to have a rigorous testing of this. The software developer need to test, the tester need to test it, we need to take the feedback of the client. So there are various phases of sandbox environment. In an implementation, a sandbox also may be known as a test server or development server or working directory, where you are free to do anything, because that is not in production. I'll quote you most recent example which I did yesterday only. I implemented a payment gateway. I developed a program for my client to integrate the payment gateway in their website, and then I said, okay, you can try now. He said, if I try, I actually have to make the payment. I said, no, your credit card will not be charged, but it will actually take you complete walkthrough from beginning to end, how your process is going to happen. So you will see that a payment is happening, but your credit card will not be charged. He said, how it is possible? I said, we call it as test environment, we call it as sandbox. So the sandbox allows to test all aspects of the program or the software or the flow without actually affecting the real database or real without actually charging the client. Okay, it isolates untested code changes and outright experimentation from the production environment or repository in the context of software development, including web development and revision control. This widely used. We cannot survive without sandbox because we need to test. We cannot directly take everything to production. If you look at various stages, we have sandboxes. Development sandbox, the first one. Frequent deployment is happening. Project integration sandbox. So development sandbox means if we have three, you can see that there are three rectangles. This is conveying the message. If you have three developers, they have their own sandbox, development sandbox. Once they are developing their modules, there is a project integration sandbox. Again, at the testing, it is again a sandbox, again an environment where nothing is final. So they can do their own testing. After they are done, they can do that integrate it with the project, and that is called project integration sandbox. Okay, then we have controlled deployment. We call it as demo sandbox, where the client will be able to see that, client will be able to try that, and or we also call it as pre-production test or QA sandbox, wherein system and acceptance testing is happening. And finally, highly controlled deployment is the production. There is no testing, it is final, done, and the client is using it now. Operations and support start with that. All right, this is what different type of sandbox we have. Let's understand one by one. Development sandbox. This is a working environment for individual developers, programming pairs, or individual feature team. The purpose of this environment is for the developer or pair or team to work in seclusion from the rest of their project team, enabling them to make and validate the changes which they are doing without having to worry about adversely affecting the rest of their project team. So they are working their own environment, their own cell. That is called development. Then we have project integration. Each project team should have its own integration environment, often referred to as a build environment or simply a build box. Developers will promote their changes code to this environment, test it, and commit it to their team's configuration management system. That's project integration. The goal of this environment is to combine and validate the work of your entire team team, so it can be tested before being promoted to your test or QA sandbox. This is second level. The third level is demo sandbox. This is the sandbox where you deploy working software, which you can use the demo software to your stakeholders, and they can use for acceptance testing purposes. This is the third. And the fourth is a pre-production test or QA test. This sandbox is shared by a separate team, typically your testing group. This environment is often referred to as pre-production sandbox, a system testing area, or simply a staging area. Its purpose is to provide an environment that simulates your actual production environment as closely as possible, so you can test your application in conjunction with the other applications. That's all. That's all, my friends. Thank you very much for watching.